Engineers innovate and create new and essential materials. They work to transform our world to ensure that resources required today will continue to be available in our future. This may take on the form of reducing CO2 production, decreasing pollution, and the sustainable mining of essential materials like metals. Many UBC engineering programs have areas of research focused on ensuring we will continue to have access to the resources we need while ensuring that these processes are sustainable and lessening the impact on our world. In this video, we welcome researchers and instructors from mining engineering and chemical and biological engineering to share some of the ways their program ensures we have the necessary resources for our future.
Hi, I'm Vikramditya Yadav and I'm a biological engineer. Nature assembles, dismantles, and recycles molecules in the cleanest and most efficient manner imaginable. Engineers like me study biological systems in order to understand these remarkable natural processes and then use those insights to improve manufacturing operations and products. To a biological engineer, a forest is a source of both raw materials and information. We harness the chemistries in trees to make biodegradable electronics, as well as rethink how pharmaceuticals are discovered and manufactured. Biological engineers unravel the mysterious ways in which bacteria mop up oil spills, and we are re-engineering these tiny machines to now rid our oceans of plastic waste. We are decoding how plants employ photosynthesis to capture carbon dioxide, and we are using this knowledge to design the next generation of chemical factories that consume and not liberate carbon dioxide. It is now possible to quite literally conjure things up from thin air, including lab-grown meat. Yummy. The future belongs to the bold. The future will be shaped by chemical and biological engineering.
Hi, my name's John Steen. I'm a lecturer in the Keeble School of Mining Engineering, and I'm also the director of the Bradshaw Research Initiative in Mining and Minerals. After the COVID world sort of recovers, we're going to see a huge upswing in the demand for metals. Why? Well, next time you go and look at a Tesla or an electric car, you think about what's in that car. And there are probably a few dozen kilograms of copper, lithium, there's nickel, and that's only one car. You think of all the thousands and thousands of cars that are being produced all around the world. And you think of all the wind turbines that you're going to have to produce to make that renewable energy, to make that car actually better than fossil fuels. You think of all the solar panels. And then you think of all the charging stations. And then you think of all the electrical networks. The challenge is we're going to have to completely rebuild the world's energy system. And that's going to require just a huge amount of metal. So here's the thing, right? If you want a sure bet, mining engineering is a pretty good bet. You'll travel, you'll solve complex problems. Okay, so, good career, good industry, good wages. But I think some of you are thinking about, well, actually, I'm really concerned about the environment. I'm concerned about the future of my family, my friends, my kids. What sort of future will they inherit? And I think you're trying to think about, well, how do I actually transform the world? It's the engineers who do that job. The engineers rewire the world. They change the technology. One of the biggest challenges facing us is how do we produce all of that metal with a zero carbon footprint, with reduced water consumption, with reduced environmental impacts. This is an enormous environmental challenge. Right? And it's going to require a ridiculous amount of engineering innovation. So you might think, well, I'd like to get involved in Google or Tesla. You think about where the innovation is really required and where the opportunities are. And again, it's going to be in places where people aren't looking. It's going to be in mining. So, hot tip, have a good look at mining, and I guarantee that in 10 years, you'll be pretty pleased that you did, because it's going to be an amazing journey for the industry and for people who get involved with it.
My name is Orlando Rojas. I'm a professor in chemical and biological engineering. Before coming to UBC, I have a long experience working on polymer chemistry. But life took a different turn, and now I'm working with materials that we find in the biosphere, mainly materials that we can harvest from trees. And trees we use in a sustainable manner to produce the materials of the future. We're doing research looking into the solution to future materials needs. The situation with the environment and climate change is a good motivation for us to do work related to the replacement of plastics so that we can ensure a more sustainable future in humanity. And one very recent example that is the tip of the iceberg has been, for instance, the replacement of face masks that are produced from polyolefins, petroleum-derived polymers, using fibers that we take from trees. Trees help us to have a clean environment. Trees fix carbon from the atmosphere and therefore represent a very interesting source of materials. And in this case, we use fibers to make the face masks here in UBC that we think can be an important advancement as far as reducing pollution. I would be very excited to meet with all of you to share many more examples of how we use nature to produce the materials of the future.